Hey everyone, and welcome to the third part of this workshop where we will be learning how to deploy a smart contract to the XDC test network. We will be learning three major things from this video. The first is to deploy a smart contract onto the XDC test network. This will be done using the Metamask setup which we did in the first video of the workshop. The second thing we will be doing is interacting with the functions within the smart contract which we have created. And finally, we will see relevant information about the deployed smart contract using the Block Explorer, which we learned about in the previous video. On clicking on the lab, it will take a moment for it to spin up the development environment. So until then, on the left, we can see the file structure, and in the center, we can see the text area to type out the code. On the right, we will have an option to deploy the smart contract once it loads, and at the bottom, we can see the terminal, which is running code that sets up the development environment. We can now see the option to connect our wallet to the app. So on clicking on the button, we see a MetaMask window opens up asking us to choose which of our accounts we want to link with the development environment. On clicking next, it's basically asking us to give the app permissions to leverage the wallet to perform smart contract deployments. That is why connecting it to the correct blockchain was so crucial, which we completed in the first part of the workshop. After clicking connect, it will navigate back to the development environment where we can see that it is now showing our balance in XDC, which is 887 XDC, and the wallet address and the chain ID we are using. So we're using chain ID 51, which we had set in the first step, and also our account number, which starts with 965. We can then click on the drop down menu to see the list of all of the contracts which we can deploy. We've pre-written a contract for you, and that is going to have very basic information. So let's take a quick moment to look at the smart contract which we will be deploying. It's a very simple calculator contract which allows us to perform the four mathematical basic operations, that is addition, subtraction, multiplication and division, on two numbers, and then returns a result. So to deploy it, we click on the deploy button on the right hand side, and we will see a MetaMask window open up. Again, we will see the MetaMask window is asking us to authorize the transaction, just like it was asking us to authorize a transaction back when we were transferring funds from our computer to our phone. So it also shows us the basic information about the transaction, like the fees it will take to deploy and the data, like the URL and everything like that. But one interesting thing which we will see, which is different from the way it was happening for a normal transaction, is when we click on data, we will see a lot of hex data here. This hex data is essentially information about the smart contract which we are deploying directly. So on clicking confirm, it will take a few moments and the smart contract will deploy. And once it does, you'll see it in the area below. So let's get rid of this one. Now that it has been deployed, we can click on it to see the functions we can perform using it. As these are all pure functions, which means that they do not modify any variables within the code, we can perform these functions without having to pay any transaction fees. So let's try all four of them out. Let's enter some random numbers like 4 and 2, and for addition it should return 6, which it does. When we divide it, it should return 2, which it does. When we multiply, it should return 8, which it also does. And subtraction should return 2, which it does. So this is a very basic smart contract which we can run. And I also wanted to point out a few more interesting things. First of all, you can see that all of these numbers are integers. That is actually because there is no way to support floating point data in Solidity right now. So types like float or double don't exist in Solidity right now. There are workarounds to achieve floating point numbers or doubles, but there is no native support yet. Hence, we cannot put something like 4.3 plus 3. That just won't work. It will give an error. Secondly, because there are no because everything is an integer here, like all other programming languages, whenever you are dividing, the part beyond the decimal point simply gets truncated or gets cut off. So if I were to divide 4 by 3, it will just return 3. It won't return 1.33. Similarly, if I were to divide 4 by 5, it will simply return 0. It won't return 0.8. And finally, it has an automatic check for division by 0. So if I were to try to divide by 0, it will tell us that there was an exception which was created because it was returning a big number which is too big for it to handle, because 4 divided by 0 creates an infinite number as seen here. The last thing I wanted to show you is the contract creation transaction on the Block Explorer. So if we go back to our MetaMask account, we can see that the contract was deployed. So let's click on it and let's click on View on Block Explorer. Once it loads, we will see that there are two interesting things which are different from the previous transaction which we had done from our computer's wallet to our phone's wallet. First of all, the to address is not a regular wallet address, but it's actually a contract address. This is because each smart contract has its own address and does not depend on another address. So this smart contract is associated with this new address, not with the address which I had used to deploy it. This creates a very interesting dynamic in the field of blockchain development where each smart contract becomes its own entity, and therefore it has powers where it is able to manage funds of its own, or it is able to manage other things within it like storage. And that is what gives rise to DeFi and decentralized autonomous organizations, or what we call DAOs. Secondly, the input data is the same data which we saw when we clicked on the confirm button. And this input data is actually the hex representation of the smart contract which we have actually deployed. This concludes our third video of the workshop. So let's do a quick recap of what we've learned till now. We deployed a smart contract to a blockchain network, interacted with the functionality which the smart contract's code provided, and explored the information a contract deployment shows on the Block Explorer.